Hello and welcome back to Galileo's Bench. My name is Greg Perugini, and today's lab is on lens parameters. Specifically, we're going to be talking about the focal length of a lens and how to calculate that. The majority of telescopes in the marketplace today are of two types: a reflector that uses mirrors to make the image, and a refractor, which uses lenses to focus the light. In our kit is a refractor telescope very similar to the design that Galileo had when he first looked at the heavens in 1609. What a lens does, it takes the light coming in, and because of the bend of the glass, brings the focus into a point called the focal point. For our lab, we need to figure out what that focal point is. And it's a characteristic of a lens. Every different lens, whatever type it is, has a different focal length. So, depending on the distance we have to an object, typical Galilean telescopes, we have an image that this will focus down, and then we have another lens that focuses on that point and brings the focus to our eye. Our eye, in a sense, is also a lens, or has a lens, I should say, that focuses an image onto the retina. If, for some reason, your lens is not focusing right, for instance, it focuses here or focuses here, you need glasses. You're either nearsighted or farsighted. So, in our kit, we have a lens, and we can use the laser that we have, and with very careful measurements, discover its focal length. So let's take a look at what we have here. As you see in the picture here, we have a laser that's just going to point straight down the center, and we could straight down the center, and you would put a block or something. Let me just grab this here, and we can focus through that lens. Okay? And it's going to make the image, the light coming in gets bent, then you're going to move it over, do it at the other end, and it's going to focus and bring the light over this way. So once here, once at the other end, and they will both focus the light separately, and where they meet for lens is the focal length, the focal point, and from that point of where the lens is to that point is your focal length. As you can see, I just have a little clip holding the mirror. You can use anything, a paper clip or whatever, to hold that, that lens up. So let's take a look again. What you're going to do is you'll shine it. I didn't show this in my demonstration, but you'll shine a light getting a point A and mark that through a lens. Move it over, probably a step or two on the graph paper. Shine it through straight, and then watch it bend to a point here. Should have that B down here. And then when I shine it through at this point, it would go up to C here. So when we look at how these all converge, this is the focal length, the focal point, and the focal length is the distance from the center of the lens to that point. A characteristic of the lens is where it focuses. So in conclusion, take your time, measure as accurately as you can, and complete the lab material as per your instructor. And good luck.